Hi guys, my name is Emilian Tanev, Principal Consultant on DecisionInc. In this video I'm going to show you probably the most efficient way or cost-effective way of having Internet of Things combined with SAP Analytics Cloud. So as you can see right now, we have one custom widget in 3 different configurations and which receives data from Internet of Things device, which I will give you detail. So let me start with the setup. We are using MQTT protocol, which is widely used in Internet of Things. It is essentially a very efficient way of exchanging small packets. And there are 3 components, the major ones. We have publisher, broker, and subscriber. So publisher sends information to the broker, and then broker notifies the subscriber and sends instantly, essentially, the data to the subscriber. And usually that the good part is that you don't need to have real IP here when you use the publisher, and these are all the Internet of Things devices. They don't need to have a real IP. They can be behind proxies. And then subscriber is where essentially you receive the data and you display it somehow. The broker, currently the one I use, is cloudmqtt.com. The reason being is that there is a free plan when I use up to 5 connections. Surely for enterprise solutions, you can use another broker. SAP also provides one. And you can also create a custom server, a custom MQTT server, which is not that difficult. It's not more difficult than HTTP server, which pretty much every organization has. Okay, so we have NodeMCU, which is essentially like a small board with Wi-Fi, integrated Wi-Fi, and you have some pins on the back and 2 sensors. So one of the sensors, this one is DHT11, which measures temperature and humidity, and the other one is light sensor. I forgot the exact name, but it is easy to find if you look for like NodeMCU light sensor. These are pretty cheap. I mean, I didn't really look for enterprise grade equipment, so this is like cost 10 quid in total, and it is used widely in home automation to sense different type of data, which is for temperature is like thermostat and so on. We have subscriber, which is a custom widget and SAC, which doesn't have any visualization, but what it does is establish the connection with the broker, and every time broker says, okay, there is a message here, it will receive it immediately, instantly, and you will see that in a minute, and then display it on the gauge, which has 3 different configs for temperature, humidity, and light in lumens. Okay, so that was the setup. Let's dive into the demo. Okay, so let me tell you what is custom widget in a nutshell. SAP released custom widgets in November 2019 as part of SAP Analytics Cloud, and in particular Analytical Designer, formerly known as Application Designer. And the intention of SAP was essentially providing a way to create new visualizations to the end client, because they are overloaded with requests for new visualizations. And fairly, you see here these 3 gauges, which there is just one type of custom widget behind, but with 3 different configs. And it can be set to a wide variety of gauges, essentially, with different ticks or labels or different colors and so on. And this is what you imagine as what is custom widget. But also, custom widgets can be something else as well. And in this scenario here, we have custom widget, which is hidden, you don't see it, but it is this MQTT client, the subscriber, which receives the message from the broker, and there is trigger event trigger. When there is a new message, it directly proxies that to the relevant gauge and displays it, as well as saving the data to the table, to the essentially as SAC planning model. Okay, so I will start with using my torch on the phone. I will essentially put the light next to the sensor, and you'll see that the values changing, as well as the data committing to the table model, or essentially the SAC planning model. Okay, and when I focus the light very closely, you'll see that the values are changing even more. Next, I will use my breath to influence the humidity sensor. So and it went to 95%, which is normal. Next, I will use my fan heater to influence the measures of the temperature. You will hear some background noise, so don't worry. We'll switch it on and we'll put it close to the sensor. So we shall see the temperature starting to change, and also the color of the scale, of the gauge, will start to change, going from green to red. Okay, so we can see it started with green and then it went to yellow and so on. So I will put it aside and we'll switch the heater. As said before, every time when we have new measurement, we save it on two different values, like last measurement as well as the particular hour when it happened. So in this case, we have something at, I think, 12 a.m. and there is some history of data down below. Finally, I want quickly to discuss what are the pros and cons of this approach, having MQTT client directly in SAC rather than going via database. So first and foremost is no requirements for database interfaces and involving different teams from IT infrastructure and so on. It is as real-time as it can possibly be, and that's because you directly communicate with the broker rather than going via database, and that database may have some triggers, and these triggers needs to be somehow displayed on SAC, likely via live connection or something like that. But it is a bit more difficult to refresh the widgets on the dashboards at the right time, because when you have this MQTT widget, you have triggers and you can control that behavior. So if you have like operational dashboard where real time is pretty much the most important part, then this is really good solution. It is controlled by business people, and that's because the acquiring of data from the broker is pretty much controlled by business people, by those who are running the app. They, in most of the cases, if something is wrong, they will just need to refresh the dashboard or the application. It is super cost effective, and that's because of all these things mentioned above. So you don't depend on more teams and you have less hardware, software, and people involved. So what are the cons? You need to have dedicated display for that, which will run like 24/7 or just during the day, which will present the data and also save it if required somewhere for historical analysis. And this can be a big cons for some scenarios if you want to have like multiple dashboards displayed on different places. And you can still have like a leading display which saves the data to this last measurement and then other displays just reading from that last measurement. But you cannot really have like multiple leading displays which like all of them saving data in the model, as you can imagine. Then broker password, so essentially the MQTT client, because it is like something in the browser, sits in the browser, you need to put your passwords, and if you have some super techie users in the organization, they will be able to reveal your password to the broker, which shouldn't be a problem, but it is worth mentioning. So every JavaScript app, if you have some passwords hidden, written somewhere, they can be reviewed by users because they're not compiled and they're accessible. Historic data probably is not as robust as going via database data acquisition, because you have display that may glitch or something else. I'm not saying that it cannot happen with database, but probably the possibility is less likely. If you have questions, I will leave my LinkedIn profile and the one from my company, DecisionInc. So if you have questions, feel free to contact me or some of my team, and we'll get back to you. Thank you.